Hello, in this video I'm going to cover acid-catalyzed alpha halogenation of ketones. And what I'm going to do is I'm going to give a few examples, and then I'll provide a mechanism from one of those examples. So let's look at an example here. So this is methyl-terbutyl ketone, and we can react it with Br2 and CH3CO2H, and this is acetic acid. And what that's going to give us is a ketone where we've substituted one of the hydrogens with the bromine. Now, unlike the base-promoted alpha halogenation, with the acid-catalyzed alpha halogenation, you're able to control how many halogens you add. So you can stop with adding one halogen, or we could add, we could give an example where we add two halogens, and we would do that by adding two equivalents of our X2, in this case Cl2, and I'll show a different way we can write acetic acid, CH3COOH, and this would put two halogens on. Okay? And the reason we can stop at one or two is that each successive halogenation is going to be slower than the one that came before it. And so if I were to form the enol of this, it would be less stable than the enol of this. Okay, and the enol is part of the mechanism of this reaction. Okay, let me show you one more, and then we'll look at the mechanism of that one. We could have a benzene ring on one side. Okay, so we could have acetophenone. We react that with Br2 and acetic acid, CH3CO2H. That would give me this alpha brominated ketone. Okay, so let's look at the mechanism of this reaction. All right. So this is going to occur, this is occurring under acid-catalyzed conditions. And so what we're going to start with here is a proton transfer. So this is my acetic acid, CH3CO2H or CH3COOH. Okay, this is the structure of it. Ooh, excuse me. And what's going to happen first is we're going to do a proton transfer. And then we have this acetate. Oops. Okay, and then we can do a second proton transfer. And that gets us to our enol tautomer. Okay, so what we're seeing here is an application of the keto enol tautomerization. So here's the keto form, here's the enol form. All right, and that can, we can now react that with our Br2 electrophile. All right, so we can have this come down. All right, so this is an SN2 type elementary mechanistic step. Okay, and we're almost at our product here. I gotta do a little erasing to get there. So we've done 2 proton transfers followed by an SN2. And then we have one last step, and that's our bromide ion. In this case, it's going to come in, and we're going to remove this hydrogen, and we're going to do a final proton transfer. And that gets us to our alpha brominated ketone. All right, and that's going to conclude our lecture on acid-catalyzed alpha halogenation. Thanks for watching.